Hello again, Math 121. Now we're going to go the opposite way from logarithms to exponentials, okay? So what we have here is a logarithmic equation because the function, the x, is inside the log's input, right? See the argument here? Okay. We have a log base 2 and a log base 2. So what we're going to do is we're going to use the inverse operation here of exponentials and logarithms to get x out of here, all right? So what we can do is we can take this guy and we can say that there's a basic log property here that says that the reality is when we add logs of the same base, which it's really like multiplying. It's like multiplying their arguments. So you'll find all this in your logarithm chapter that's been assigned. But if we add logs with the same base, then we really just multiply their inputs. So this could be rewritten as log base 2 of x squared minus 3x, which is equal to 2. Okay? So what we've done is we've just made this one log instead of a log plus a log, right? Okay, so then the next step here is we're going to use the same base as the log base 2, and we're going to raise the function to that base. So we're going to say this whole function, we want to raise it. It's going to be the input of my exponential function with the base 2. See how the base is the same? But again, the golden rule of algebra, whatever I do to one side, I have to do to the other. So notice that these blue parts are now the input of my exponential function. So what happens is these guys cancel out, right? And what it does is it brings the input down to the playing field. So we get this. 2 squared we can simplify and make to be 4. Remember, our goal here is to get x alone, to solve for x. And I see something very familiar here. I see a quadratic, right? So sometimes when we do this math, we're back to the quadratic unit, and we're trying to find the factor set that made this from the last unit, right? So again, we're looking for something that can make a negative. So we got negative 4 plus 1 makes negative 3. So we get x minus 4 and x plus 1 gives me that middle term, which means that x will be equal to 4 or negative 1. Okay? So we have 2 inputs that could create this, right? So we need to be aware of these type of problems, but we're still using that inverse operation relationship to undo the log to get the input out so we can get x alone. Remember, the problem with solving these is the x is in these funky inputs, and we got to remember logs and exponentials are like exponents, and in PEMDAS, they go second. So I would have to do those before I can do any kind of adding, subtracting, or multiplying, right? So that's the real issue. So we can use the same base to wipe out stuff that we don't want to get the input to the playing field so that we can get solving for x. All right? All right, good luck on any of these solving things. Remember to memorize your logarithm properties like the one I just used. Adding logs of the same base is really like multiplying their arguments. There's properties for division. There's properties to change base. Please take a look at those. You need to see those. Thank you.